Okay, today we're talking about graphing tangent and cotangent functions. If we can recall, in the unit circle, we have these coordinates x and y, and our tangent is the ratio of y over x. So you'll notice on this worksheet here, or these notes, that you'll see a tiny unit circle here, where each one of those is an x and a y. Okay? And we can use those to calculate the tangents. Also, you guys had a table that we did back in Unit 1 where we filled in all of these values from the unit circle. So I would encourage you to go back and look at that, and we're going to be looking at tangent and cotangent values today. Notice here that the y-axis is centered for this graph. So what we're going to do is we're going to start here at 0. And we're going to say, well, what is the tangent value of 0? So we take x over, y over x, and so that leaves me with 0. And then we're going to think about those critical values. So when we're looking at tangent, and I believe before the break, your last skill check was the unit circle with all of your tangent values. Or we could look at our table here and figure out what are those pretty tangent values, things like zeros, ones, negative ones, undefined. And so we're going to see that those occur every pi over 4 radians. So we're going to look at our pi over 4s. So right here is going to be pi over 4, then we got pi over 2, and we've got 3 pi over 4, and I'm going to fill in the rest of that table with all of... Okay, so I filled in all of my positives, so going from here all the way to 3 pi over 2. And now I'm going to look at my negative angles, but I'm going to go in pi over 4. So negative pi over 4, negative pi over 2, and I'm going to go in this direction. Okay, now that I have my table filled, I notice there's a pattern here. Undefined, negative 1, 0, 1, undefined, negative 1, 0, 1, undefined, etc. So it repeats every pi radians. Every pi radians. That's actually going to be our period. So with sine and cosine, we got back to the original value after we completed one revolution of a circle, which was 2 pi. But with tangent, I only have to go pi before I get to the exact same value right here. So like this right here is a tangent value of 1. This is a tangent value of 1. And that's half a circle. So that's pi. So the natural period for tangent is pi. Okay, now these undefined areas, those are actually asymptotes. So when 0 is in the denominator, it's not possible to have a value there. So at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2, we have these asymptotes. And asymptotes are back from Algebra 2 with exponential functions, rational functions. They're those imaginary lines that the function can never actually touch, but it can ride right next to it. Okay, so it looks like 1, 2, 3, 4. So 1, 2, 3, 4. This would be a negative pi over 2. 1, 2, 3, 4. 1, 2, 3, 4. That's going to be 3 pi over 2. 1, 2, 3, 4, 5, 6, 7, 8. And that would be negative 3 pi over 2, where each one is a distance of pi. Okay, now we're going to plot our points. So we're going to start at 0. So that's 0, 0. And that pi over 4, which is halfway between 0 and pi over 2, I'm going to go up to 1. And then if I go backwards, to negative pi over 4, I'm at negative 1. If I continue to move forward, at pi over 2 it's undefined. At 3 pi over 4 I am at negative 1. At pi I'm at 0. And at 5 pi over 4 I'm at positive 1 and back to undefined. If I go in the reverse, then I get to negative pi over 4, which we have. Negative pi over 2 is undefined. Negative 3 pi over 4 is going to be a positive 1. And then go another 2, be at 0, another 2, I'll be at negative 1. And you see these 3 dots. Well, a tangent function is kind of like a cubic function in that it kind of swerves down like such. You just do the best you can there. And there's my tangent function. Okay, the domain here, so there are restrictions. And this gets kind of tricky because the way you have to list your domain is, first of all, it's all real numbers except each of these asymptotes. So I'm going to say my first asymptote, which is at pi over 2, plus each asymptote is a distance of pi. So we're going to put an n times pi. N is going to be a multiplier to get me to my specific asymptote, but I also have to define n. So n is going to be an element of the integers. And that z represents integers. This funny looking e represents an element, and n is going to be that variable that I'm multiplying to get each of these asymptotes. So that's kind of confusing, a big step from sine and cosine with domain. The range, however, how low does this function go? Well, it goes to negative infinity. How high does it go? It goes to positive infinity. So my range now is negative infinity to positive infinity. All right, so if each period is pi, you'll notice that each one of these special points right here is the same distance apart. So right here, one thing to keep in mind is you can still find the important values by dividing the period by 4. So we recognize our period. We can use the quarter periods to find the critical values. All right, the next example right here, negative tangent of 2 theta. Okay, a lot of the same things are still true. This right here still represents frequency. And this right here still represents a reflection. Now, whatever that number is in front of tangent here, we call that like a multiplier. It still represents a vertical stretch or shrink, but we do not call it amplitude. It is not considered amplitude anymore. Amplitude only exists in a wave function. Okay, and then of course if I saw anything out here, that would be a vertical shift, and if I saw anything being added or subtracted inside the parentheses, that would be a horizontal shift. Those all stay true. For this one, I'm going to have a reflected tangent, and my frequency has changed. So remember from sine and cosine that the period was the natural period divided by the frequency. Well, for tangent, our natural period is pi, and we're going to divide that by the frequency. Likewise, the frequency is the natural period divided by the period of the function. So if my frequency here is 2, then my period is going to be pi divided by 2. Okay, and then my quarter period, where I get my critical points, would be pi over 2 times 1/4, which is pi over 8. Now, if I look at my scales here, if that's pi over 2, then this is pi over 4, and half of that is going to be pi over 8. So each one of these squares is pi over 8. Now, the thing about tangent is that it is always centered on the y-axis. So unless there is a vertical shift or a phase shift, tangent will always have a 0, 0 center. It is always centered on the y-axis here. Okay, so I can always start with 0, 0. All right, now my multiplier is 1 and it's a reflection. So you'll notice here that from 0, 0 to the right I go up 1. But for a reflection I will actually go down 1. And I'm going to go every pi over 8 to my next critical point. So here I'm going to go down to -1. And then another pi over 8, I'm going to have an asymptote. Okay, another pi over 8, I'm going to go up 1. Another pi over 8, I'll be 0. Another pi over 8, I'll be at -1. And another pi over 8, I will have an asymptote. And then I can reverse that. So this will be a +1. Another pi over 8 will be an asymptote. Another pi over 8 will be a -1, a 0, a +1, an asymptote. Okay, so it is definitely reflected, and it was a horizontal shrink. So there is no phase shift. The period here was pi over 2. The vertical shift did not exist, and yes, there was a reflection.